Hello everyone, welcome back to our channel. Today we'll be discussing about one of the A-level topic from Pure Mathematics P3, subject code 9709, that is differential equation. The first question over here is, what is differential equation? Now, as the name suggests, differential, then equation. Anything which involves, any equation which involves a derivative. Now we have already done calculus, means we have done differentiation and integration. So what do we mean by derivative? Either in the form of dy by dx, or you can have your second order derivative, or if required, third order derivative. So any equation which involves a derivative is known as differential equation. Okay, now let's consider the types of differential equation. Now we can segregate differential equation in two ways. One is on the basis of order. Second is on the basis of degree. Well, degree, this is not part of our syllabus, so we'll be only discussing about order. Let's suppose if we have a differential equation, dy by dx equals to ln x plus 5. Okay. Now, if we can see that there is a single derivative over here, that is dy by dx. So we'll say this is first order differential equation. Now, let's suppose if you have some equation like d square y over dx square dy by dx plus sin x. Now, over here we have two derivatives. One is first order derivative. Second is the second order derivative. So what is the highest order of derivative in this equation? That is second order. So this equation is second order differential equation. Similarly, if we have an equation which involves a third order derivative, let's suppose if we write down some random equations. Now, in this equation, there are all the three derivatives. This is first order, second order, third order. But what's the highest order of the derivative in this equation is third order. So we'll say this is third order differential equation. Clear with this part? Okay. Now, let's understand a scenario. How do we form a differential equation? So there is a situation given to us. This is a simple situation to make you understand how we can form a differential equation with a given scenario. Now over here, a object is moving through a liquid so that the rate at which its velocity decreases is proportional. So first thing to note over here is the rate at which the velocity decreases. Means what's given to us is dv by dt. That is the rate of change of velocity. And this velocity is proportional. And proportional to what? There is a velocity which is decreasing. So I write proportional and negative, which represent the first statement. Now the second statement over here is when it enters the liquid, it has a velocity of 5 meters per second. And the velocity is decreasing at a rate of 1 meter per second square. Now, looking at this unit, what do we assume? Okay, this is acceleration, that is 1 meter per second square, and that too decreasing, so we'll have a negative sign over here. Now, we know acceleration is rate of change of velocity. And this acceleration is decreasing. And at what point? When velocity is 5 meters per second. Okay. Now let's come back to this part. Now we know this is a relation with proportionality. Now we need to change this proportionality into an equation. So whenever we remove this proportionality symbol, so what do? We multiply with a constant. So where k is a positive proportionality constant. Okay. Now, using this information, we'll find out the value of k. Okay. Now, what do we know over here is that dv over dt is -1, -k, and velocity is 5. So which implies that the value of k is 1 by 5 or 0. So now I can read out this differential equation as dv over dt is equals to negative v by. Clear? I hope you have understood the situation. Okay. Now let's start solving a differential equation. Now to solve a differential equation, we can just simply use whatever we have learned in calculus. Though this differential equation is also part of calculus, but at start we have learned about differentiation and integration. So while solving differential equation, we can directly use integration. Means when there is a simple equation, you can just directly integrate both the sides of the equation with respect to x. Let's suppose if we have some equation dy over dx, sorry, dy over dx is equals to 6 x plus 1 whole square. So this is a differential equation. Yes, there is a derivative over here, and this is a equation. Now simply to integrate this, what I'll do is I'll integrate with respect to x. So I'm integrating left hand side with respect to x. I'm integrating right hand side with respect to x. Now, though we can cancel this out, but we don't do this. Now integration simplifies this. Simplify this part, left hand side will get integration of dy. And over here, 6 is constant, I'll keep it outside. X plus 1 whole square. Now integration of dy, y. Integration of this is 6 x plus 1 whole cube over 3 plus c. So over here, we have used this concept, integration of x to the power n is x to the power n plus 1 divided by n plus 1. Yeah, definitely we are using with respect to dx. The same concept. Now, whenever you write down plus c, now this is your, this represents a general solution. Now, whenever you are finding out the equation of the curve from the given differential equation, you may have two situations. One, you will be finding either the general solution, or second, you may be finding the particular solution. So we'll be discussing about this in the next part of the video. Okay. Now let's move out to a new method when just simply integrating with respect to dx will not work. For example, let's suppose if we have equation dy by dx is equals to x, y. Now in this scenario, integrating simply with respect to x will not work because over here we'll have two variables, that is x and y. So over here we'll use this technique of separating the variables. So technique of separating the variables. So what I can do is I'll just move all the things which are related to y on left hand side and all the things which are related to x on right hand side. So what do I get is dy over dx 1 by y is equals to x. Okay. Now y is on one side and x is on one side. Now I can integrate with respect to x. So once I start integrating with respect to x, both sides, what do I get? Now we know integration of 1 over y dy is ln y, mod y, and this would be x square plus 2x. Now this equation is also a general solution of this differential equation. Okay, now to make y as a subject, what you can do is you can take e on both sides, so you get y e to the power plus c, which can also be written as y equals to e to the power times e to the power c. Now see, e is a constant, c is also a constant, so this complete I can assume a new constant. So I write down this equation, we write as d e to the power, where d is your arbitrary constant, just a new constant. Okay. Now, what about the particular solution? Okay, we got the solution, which is general solution. What do we mean by particular solution? So let's understand the difference between a general solution and a particular solution. So I'll take a simple example. Let's suppose you have something dy by dx equals to 5. Okay. Now, this is a differential equation separating dy by dx, integrating both sides, and this is the integration of 5 dx. So we get y is equals to 5x. Okay. Now, my equation can also be y equals to 5x plus 7. Now, same equation can be y equals to 5x minus 7. Y equals to be 5x minus half. All these possibilities are there because when I differentiate this equation, I'll get this. When I differentiate this equation, again I'll get this. When I differentiate this equation, I'll get this. When I differentiate this equation, I'll get this. Okay, so there are lots of possibilities. That's the reason we are using the C over here. See, what do I get is over here, whenever I write down 5x plus C, so I'll get all the equation of line whose slope is 5. Okay, but if I want to find a particular equation of line, then I need some additional information. Means some information which is related to the initial situation. Let's suppose if the information is that y is equals to 2 when x is 0. Okay, if this information is given, okay, now if I substitute this information in my general solution, so what do I get? 2 is equals to 5 times 0 plus c. Now if you simplify, you'll get c is equals to 2. So if I write down this equation, y is equals to 5. Now this is a particular solution. Now over here, you are not getting all the equations of line with slope 5. No, you are getting a particular equation of line whose slope is 5 as well as y-intercept is 2. But when you write down y is equals to same thing in the form of c constant. So this represents a family of lines whose slope is 5, but we don't know the y-intercept. So there are so many possibilities. If you see the graphing part, let's suppose the slope is 5. This. So there can be so many lines passing and having different y-intercept. But when you have the initial situations with you, so you'll get a particular equation of line. Okay. Now let's come back to the previous question. What we discuss over here in the same question, this is our general solution. Now, if I want to get a particular solution, let's suppose there is an equation y equals to 2 when x is equals to 0. This is the initial condition we know. So we substitute ln2 is equals to 0 plus c, which implies c is equals to ln2. Now, if I substitute this over here, so what do I get? Y is equals to e by 2 plus ln2. Now, if I simplify this, e x square by 2 e to the power ln2, which can be written as 2e x square. That's the property of e and ln. So now this becomes a general equation. Okay. Now we have understood this part. We have also discussed about the general and the particular solution. Now there are key points which you need to take care. One, we have already discussed about separating the variables. Now integrating both sides. See, not every time you have to write down this dx by dx. So you can simply use this concept. Once this is just to make you understand that we are integrating both sides with the same thing, means with respect to x. Now we have discussed how to find a general solution and substitute any given conditions to find out a particular solution. General solution will give you a family of possibilities. Particular solution will be specific. Okay. Now, if you have a doubt, you can always differentiate your equation, whatever you are getting, to check whether we are getting the same differential equation. Now, there are important things to remember, that is, take care of modulus sign in the expression such as ln x, because we know that the value in ln and log should be positive. And when finding a general solution, check to see if values excluded when variables separated are possible solutions. At times we cancel out variable and we lose out one of the possible solutions. So we need to be little careful about this. So I hope by this you will be able to revise the key concept involved in this topic, differential equation. Now you can practice exam style questions, and I'll be coming up with one more video on this where we'll be solving past year exam style question under the topic differential equation. Thank you for watching this video. Have a nice day.